This presentation is entitled How My Life Would Have Been So Much Better If You Had Used the NetBeans Platform. A title like that would not typically be a title of a presentation by someone who is from the organization that provides the framework being described. But the history of this is that the original person who was going to do this presentation ultimately wasn't able to do so because the application about which this presentation is focused on is too close to the company from which this particular person comes. So they're not allowed to talk about this particular product, but since I have no relationship with that particular organization, I am able to do so. We will start by very briefly, here's the agenda. We'll look at the application very briefly and schematically at its architecture. At architecture, it might be missing, and based on the title of the presentation, one can guess what that architecture is. And look at the main features of that architecture, and hopefully at some stage do a couple of demos as well, so you can see how this all applies in this context. So who I am Geert-Jan Wielinga. I'm a product manager within Oracle for the NetBeans team. I've been with NetBeans for a long time. Originally, I came from Sun Microsystems, and I guess Oracle kind of inherited me along with the takeover. And yeah, so this is all about the NetBeans platform. And based on earlier sessions that have happened during this conference, it turns out that there's quite a lot of people using it. But let's see how it is in this room. How many people here would consider themselves users of the NetBeans platform? Okay, that's quite a lot. And how many of you actually have NetBeans platform products in production at a customer site? Okay, great, cool. So this session will be definitely interesting if you are kind of new to the NetBeans platform, but you might learn things even if you're not. Especially when it comes to the demos, you'll see some things that you might not have seen before. So here's the application. It's some kind of typical back office application that you can actually download, at least the jar, not the sources, from this particular site. It's some kind of application that connects to an external device. In this case, some kind of video. Imaging related devices, and the application is used to control those external devices. And this is one of the typical use cases of the Java desktop. And these kinds of applications are found all over the place. And they typically start by doing Java -jar on the command line, followed by the jar file. And then a small application starts up that makes some kind of connection to some external device, whatever it is. And you can then control and monitor those devices. Therefore, it's a relatively simple application. It has requirements like creating connections, storing information in some special format, opening files. The benefit of this being a Java application is that it is possible to run this on multiple different operating systems. I actually have it running. Here it is. So here it is running, and you see that there are different tabs representing different files, in turn making connections to external devices. You go to File, New, and create one of these new file types in this application. You see that there's a control panel on the left-hand side, which is the same for each of these different types of documents that you work with. It's a very typical standard application with a menu bar and a toolbar, of which there are probably millions around in the world. The architecture, if you are going to be incredibly simple about it, is like this. We have the Java runtime, and we have the application on top of it. However, the missing architecture in this context is a layer in between. So this is the NetBeans platform. And this is really what the focus of the session is about, is what that layer between the Java runtime and the application offers. It's really more focused on, in this session, on this particular architecture than step-by-step instructions for how to use it. It's really, you're going to get a high-level global view of that architecture. So what is the NetBeans platform? You're going to see this in some more diagrams, but it's the framework beneath NetBeans IDE and many other applications, many of which we will never know about, because often these kind of applications are not only used in the back office or in-house or somewhere, but often in domains where they don't talk about their applications at all. You don't see many screenshots of air traffic control and defense and banking applications, because typically these are in secure environments behind a firewall, and the developers working on those projects often consider that their work to be pretty mundane and boring, and they've been doing it for many years already. They're not blogging excitedly about the new features they're creating. They're just doing their 9-to-5 job. That's typically the scenario where these kinds of applications are developed. So this middle layer that you see here, the NetBeans platform. So let's look more closely at this, what that consists of. So this is that middle layer broken down a bit further. So you see 3 levels there. The lowest level in the NetBeans platform terminology is comparable in the Java terminology to the JRE. So this is the core runtime of the NetBeans platform, in the way that the JRE is the absolute fundamental basis of Java applications. And this is the only part that each application that makes use of this NetBeans platform layer must have as a mandatory component. And this is an important point, because typically when you start using a new framework, you tend to think to yourself, well, I'm just going to have to buy into the whole framework, and I know I won't need all of it, but some part of it I will need, but I'll just accept the fact that there'll be lots of stuff that I'll just have to include, many jars I'll have to include, just for the sake of using a subset of them. In the case of this framework, that's not the case, because it's modular, and you can choose which pieces you actually want to use. And this lowest layer is the only mandatory part, and it consists of 6 jars, as you'll see. The middle layer here in the NetBeans platform consists of primarily GUI components, and GUI components which are relevant for the for typical Java desktop scenarios. A window system, a number of swing components for displaying complex data, a mechanism for synchronizing those different views. Basically, the view layer solving many problems that one typically has when working in the view layer. But this entire layer is optional, and I'll show a couple of demos where you can see the impact of that. The highest layer that you see here, consisting of here a number of modules, one should see as plugins. So these are modules plugged into that architecture, and these are the external contributions made by you as a developer. So not only do you have the JRE, but you also now have the NetBeans core runtime and probably a subset of the NetBeans GUI component layer, and then on top of that, you add the domain-specific parts of the application. And by the time that you start contributing to the application, there is already so much that is provided that you find that you work on a very domain-specific, in a very domain-specific way, because nothing that is generic should be your concern anymore. If you're creating an oil flow application, you'll only be working directly with your oil flow objects. You'll not be working with setting up a window management system, setting up a start sequence, as you'll see a bit later on. So this is the generic architecture of all applications. This is the architecture of NetBeans IDE, of Gephi, visualization tool, of three actually Duke's Choice Award winners from this year, AgroSense, open source file management system, NATO's air defense system, and a refugee agency system used to register and manage refugee data. So many applications and all sharing this common architecture, which of course has the benefit that at some point this becomes a kind of pseudo standard. So once you've been working with this in one context, switching to a different context in a different organization becomes simpler because the architecture is shared among different organizations. So here's the core runtime. So if I go back to where I was before, this is the lowest level in a bit more detail. So this is the kind of the JRE of the NetBeans platform is here and consists of, in this diagram, as you can see, 6 different blocks, and each of these blocks are jars. These are just jar files. In NetBeans platform terminology, these are also modules. So there's some metadata added to these jar files, and there's a deployment format which wraps this metadata and these jar files into another format, which is comparable to a zip format. So you could unzip these files and look at the content. What is inside here? So what are these in some more detail? So what does this NetBeans core runtime provide? A startup sequence, first of all. So using the NetBeans platform as a starting point, you will never find yourself writing the startup sequence of the application because it's already contained in the core runtime. So there's a startup jar and a bootstrap jar that provides the startup sequence. However, of course, you might be thinking, okay, but I do need to initialize some things when the application starts up. So there are entry points into each of the modules that you provide. Lifecycle entry points. So when the module is loaded into the system, when it's unloaded from the system, you can initialize and uninitialize parts of the application. So that's the first really big benefit. You have a startup sequence predefined. Optionally, you can even override that startup sequence, but that almost never happens, and it's normally a sign that you're doing something wrong if you're thinking about overriding the startup sequence. There's also a module system. So exactly what Jigsaw could be for Java developers. So not looking at Jigsaw's role in breaking up the JDK into smaller pieces, but Jigsaw's role as a module system is what the NetBeans module system also is, and working in a very similar way to OSGI. And in fact, you could use OSGI inside NetBeans platform applications. So if you have OSGI bundles, you can include those inside your application on the NetBeans platform. However, typically, if you have an OSGI bundle, you created that in the context of Eclipse RCP, where SWT is used. So you're not likely to be integrating SWT components with Swing components. But if you have some standard jar file with some domain objects as OSGI bundles, you can include these. What the core runtime also has, which is very useful, is a virtual file system. So every single NetBeans platform application has a file system in the same way as a computer has a file system. And when you install applications onto a computer, folders and files can be created. In the same way, when you install modules into your NetBeans platform application, virtual folders and files are created. And in that way, the NetBeans platform is extensible. Because, for example, the menu bar of the NetBeans platform is built by a component within the NetBeans platform looking for a particular folder in that file system. So it finds a folder called menu, and all the actions registered in that particular menu folder are loaded into the menu bar. The toolbar is built in that way. All the different parts of the NetBeans platform, all the GUI components are or should be extensible in that way. And your own components can also be extensible. So you could create dialogues in your application that external contributors could extend by adding new panels into it. If they register those panels in a predefined place that you have defined for them. In your documentation, your developer documentation, you say, if you want to have your panel appear in this particular dialog, then you register it in this particular folder in the file system. So this is a very useful feature as well. And finally, there is a loosely coupled communication mechanism. So based on event listeners, enabling modules to communicate with each other in a well-architected manner. So rather than making direct links between the different modules in the application, there is a fixed infrastructure by means of which you can publish objects and listen for them in other modules. So this is the NetBeans core runtime. This is, again, this lowest level, concerned with things that any application needs and solves these particular concerns in a standard manner. So here's a list of advantages of the NetBeans core runtime. So the fact that there's a module system means that you can organize features in the application into different containers. Now, normally you would do that within jar files, and within these modules you have jar files. But the benefit of having an additional layer above jar files is that you can organize features into modules, which is something that you don't normally do with packages. You can't put a particular feature into a package. That's not normally what packages are used for. A module system also enables you to easily assign tasks to different people within the organization. So you have 10 developers, and you can say, you three work on this particular set of features which are put into different modules, which is, again, not something you can do with a jar-based system. You can't say, work on these 10 packages within the application. But this is generically true for any module system. But this is something that you have built in natively into the NetBeans platform. Because you have a module system, you also have the possibility of combining different modules into different distributions. So in the case of NetBeans IDE, for example, we have a PHP distribution which includes only modules relating to PHP functionality, and a Java distribution. And we could make different distributions containing different features for different end users. This is something that's not possible if you have a monolithic piece of code. Also, in the NetBeans module system, as an OSGI, you can version each of the modules in your application. So in addition to having a version for the whole application, you're able to version each of the features which are in different modules. And the advantage of that is that you can more easily track the changes that are taking place in your application. So you would typically, for example, have one module with domain classes, which would not change very much. And you would have another module providing a view onto those domain classes. And that module with that particular feature would undergo more change. Especially, for example, with JavaFX, you would produce a new a module providing JavaFX components. You would increment that module. And if you then look at all the versions of all your different modules, you can see where you are changing more quickly, which is also useful information in analyzing the architecture. What's also possible, and a big advantage with this system, is the possibility to create clean APIs and extension points. So there is a class loading mechanism built into the NetBeans platform by means of which, by default, anything found inside one module cannot be reused in any other module. So that's a default state. You have maybe 20 modules. Everything inside each of those modules is completely isolated from all the other modules. Only once you make the explicit decision to share code with other modules can you, as the author of a module, say, okay, these packages inside my module are available to the rest of the world to use. And then other modules that need to use code from that module need to explicitly set a dependency on that module. And in that way, you can't make the accidental dependencies between different subsets, subcomponents in an application, which is the basis of spaghetti code, because people quickly reuse a utility method from somewhere else in the application without thinking of the consequences, without thinking of what the dependencies of that utility method are. And the author of the utility method changes it and breaks code somewhere else. In a modular system with this class loading mechanism built in, you can hide those utility methods and utility classes from the rest of the application, so that people can't accidentally begin using your code, and which is especially valuable in large applications that have existed for many years, where spaghetti code is more likely to exist. And these kinds of mechanisms are really there to keep an application sustainable over a long time, so that you don't have to rewrite it from scratch every few years when it becomes too much of a nightmare to maintain. So there's also the mechanism for listening to events across modules and for listening to objects being published. And so there is also built into this a context. There's a context of the application, which is comparable to the service loader class in JDK6. But here the context is not only application-wide, but also per window. So each window in the application has its own context. And even each item in a tree component in a NetBeans platform has its own context. So you can publish objects into the context of the application, or into the context of the window, or into the context of the items in a tree. And depending on an object being available, other objects can become enabled or disabled. So for example, a save action can become enabled if a save object is published into the context of a particular object. So this is really the mechanism for creating a context-sensitive application which again is a concern for large applications with many different kinds of users. So you don't want to have all your menu items and toolbar buttons enabled all of the time. For example, a save button when there's nothing to be saved. So there's a very nice predefined built-in concept of a context into which object can be published. And it's a very fine-grained context, but can be used to the extent that you need it. And the final point here with the core runtime, no need to write a startup and shutdown sequence because that's already predefined. But again, this could be overridden if needed. So this, as you can see here, there are no GUI components. These are all low-level service infrastructure concerns. Meaning that, and this is why the whole middle layer, the GUI component layer, could be replaced with another layer, providing different components from a different language altogether, because there is no mandatory dependency on specific GUI components. So returning again to the diagram with which we left, we've looked at the core runtime, the lowest level, and seen the advantages of those features that are all baked into the NetBeans platform. So now let's go one layer higher, which is the layer of the GUI components, and where I can show some demos. So if you break it down, these are the key GUI components. So a windowing framework. If an application becomes any kind of size, you need more than one single JFrame. You need to be able to detach windows, and think for example, of stock trading applications, or of air traffic control applications, or any kind of monitoring application. Typically, the user has multiple monitors, and they want to be able to undock windows and move them onto multiple different monitors and view data, and those different views should all be synchronized with each other. So not only do you need to have the possibility of undocking windows from the application frame, but also the ability for those different windows to be able to be aware of each other. So that's a lot of work. There's this, two options. Either you write this yourself at the point where it's needed, or actually there's three options. One is don't have a window framework. The second option is write it yourself, and the third is use an existing one. And in the using existing one option, there's definitely interesting swing components that exist that you could use, for example, from JIDE. There's the JIDE docking framework, and there's various other existing windowing frameworks. But typically what these provide is only a windowing framework, whereas in the case of the NetBeans platform, you have a windowing framework plus the core runtime with this module system, the file system, and the low-level service architecture. So you get a whole bunch of other things in addition to the windowing framework. The second thing is the selection management. In the beginning, it seems very opaque and very abstract, but once you start looking at applications and you see how they work, and how when you have multiple windows, when something is selected in one window, something related should be selected somewhere else, and you have a properties window and you have multiple different views, you realize that you need some kind of functionality like that. And this is built into the GUI component layer enabling multiple views to be synchronized with each other. A third item that's really very, very powerful and useful is in the case which is, when is this not the case? When you have business objects of some kind, you're creating an application for oil flow or for car design or whatever, and you have a car object or even an oil object, you want to quickly visualize that to the user in some kind of a visual component in a node hierarchy showing multiple of your object. And there is a kind of a data binding mechanism in the NetBeans platform which lets you visualize your business objects by providing implementations of wrapper classes, of visual wrapper classes around the business objects. And once you have those wrapper objects, which are called nodes, then you can display those nodes inside multiple different swing components. And all of the NetBeans platform swing components are aware of this node class, which is comparable to a model class, in the same way as you have an abstract list model and a default tree model, and all of the different swing components typically have their own model. With the NetBeans platform, there's one model that all of the NetBeans platform swing components know what to do with. So this enables the selection management mechanism to work, and also the objects to be visualized inside these swing components. Another very important thing, at some stage you're creating a menu bar and a toolbar, and not only do you with the NetBeans platform have both of these already when you start the application, it's a predefined menu bar and toolbar, but there's also a nice mechanism for registering these, for registering action listeners. So you have a plain action listener like you would have in any Java application, a plain normal action listener, no special NetBeans platform class. And you need to register this action listener into a folder in the virtual file system. And there's a folder called menu, and this is the content of this folder is what is put into the menu bar. And the action listener and the way that you've registered the action listener determines what icon is displayed, what display name is provided, and even whether or not under what conditions the action is enabled. And all of this information is just defined inside of annotations, which a NetBeans platform annotation processor turns into registration entries. So these are the key components on the GUI level, but there's a number of other things to be aware of and that you get. And some features you only find after having spent months implementing it yourself, and at the same time you're learning about the NetBeans platform, and you look into the source code, and you look into other applications. And this is also the nice thing about having a shared framework. There's many existing applications, and then you can wonder to yourself, how did they implement that? And then there's a mailing list where you can communicate with all of these people who are creating these applications. And often they'll tell you, well, it's just this and this API from the NetBeans platform. And if not, many of these applications are open source, as is NetBeans IDE, so you can take any of the code that you find interesting and include it in your application. You can literally take any piece from NetBeans IDE. If you're going to change those pieces, then the licensing terms determine that you should contribute your changes back to NetBeans. But if you just take the code as is and include it in your application, then there are no licensing concerns. There's also a customization dialog. Another typical thing, you want the user to be able to change the background or change the fonts or change some setting in the application. And there is a predefined dialog together with an API for extending that dialog. And that in turn, if you look in the source code, gives you an opportunity to learn how that is done. So you can create your own dialog based on how it works with the options window in NetBeans. That is extensible then. Also Java help support. So I think the only disadvantage with how easy it is to create, so by Java help I mean when you go to the help menu in the application and you click on help, you get a window that shows you some HTML content. Only problem with the fact that it's so simple to create with the NetBeans platform is that there's no excuse for not writing help content anymore. And the update mechanism, so typically you distribute the application to the end user, they find bugs, and you say to them, okay, we'll fix the bug, and now wait until the next release of the application to benefit from the enhancements we've made. With the modular system, there's the possibility at least in this case, of incrementing the version of your module and just distributing that module. So in fact, the incremented module becomes a patch for the existing module that the user has installed. And there's also a nice mechanism for publishing these modules. So there's an XML file that can be generated, inside of which all of the modules that you want to publish can be registered. And you can then put this XML file onto a server somewhere, together with all of the modules that you want to make available. And then you could pre-register this update center into the application, or let the user add it themselves. And in fact, to really crystallize what that is, it's an app store. So you can create an app store for your application, just like iPhone App Store, Android App Store, a marketplace. So potentially a marketplace where you could sell features to the end users, or make patches available, or you could have different update centers for different kinds of users. So there's admin users and there's normal users, and they need different features. So it's really a lot of opportunity there for providing patches, for creating a marketplace, and all of this is provided out of the box. Also, something in the application that we started with, I had to go to the command line and type java -jar and then the jar file, which is not something that an end user is going to be very comfortable with. So with the NetBeans platform, if you use NetBeans IDE as your software development kit, you can generate an installer. For each operating system, you can generate a different installer, or a web start enabled set of files. So the distribution side is also taken care of. So with that said, I want to show a couple of things. So first of all, with the windowing framework. So the default windowing framework is as NetBeans IDE has it. So something like this. And here you can see also the communication mechanism in action, because you can see we have a properties window on the right-hand side, and we have a different window displaying our projects on the left-hand side. And as we move up and down from one file to another, the properties window changes. Obviously it changes. We're not surprised about that, but the mechanism by means of which this happens is a key factor, and that is on this side we publish an object, and on the properties window side we're listening for an object. And this properties window is listening for a generic standard object. So not a specific object that you've created, but the wrapper class around the business object. So if you create your own wrapper around your own business object, then automatically it will be displayed in the properties window when you publish that wrapper object around it. So this is the standard typical way that the Windows system works, so with the docking and the undocking and so on. So all standard features. Since NetBeans 7.1, I think, you're also for the first time able to undock groups of top components. So you see a float group, and I believe this was a JDeveloper requirement. So this is one reason why I think the Oracle takeover of Sun was so cool, because it resulted in a much better Windows system for NetBeans. Because JDeveloper is now based on the same infrastructure. And now Oracle has multiple different projects all sharing the same framework, which means in some cases conflicting or more interesting requirements, not requirements from one product, but from multiple different products. So we try to combine all of these different requirements into the Windows system, for example, which leads to the Windows system being more expressive for anyone creating applications on it. So here I was. So I'm going to dock the group again. So this is just a standard Windows system, but here are a couple of other things, and each of these come from tutorials. So if you were at the earlier session showing JavaFX inside the NetBeans platform, but there, in this case, it's using the standard NetBeans Windows system, but just to give you a colorful picture to look at, all the graphs, and this is JavaFX embedded inside the NetBeans platform's Windows system. So with all these special effects, so if you missed the tutorial on this topic from 10 to 12, it was really very interesting. And the source code of this is also available So you can see the charts change, and if I select something here, but the point is that there's a swing J table here, and if I change the value, then all of the charts are updated at the same time. And so this is really not, I would say it's almost trivial to create with all the documentation and tutorials that we have on this topic. So creating really interesting chart-based applications is completely possible. But to look at the Windows system, here is a completely different way of working with the NetBeans Windows system. And it's kind of reverting back to a pre-Windows system situation. Once it's started up. So what we have here is, well, first of all, you see you have no menu bar, no toolbar, proving the point that that's completely configurable. But secondly, this doesn't look like the NetBeans Windows system at all. And in fact, these are J internal frames inside of a J desktop pane. So you can take a standard desktop pane, put it inside of a NetBeans window, which is just a swing container into which you can put any swing objects. And inside of that desktop pane, you can put in your internal frames. And if this is what you need, you know, there are applications that have this kind of desktop appearance. So it taking over the whole desktop, and you can minimize into the desktop pane at the bottom. So this is, but so the benefit is, I mean, this looks like a standard swing application, but the benefit is that you have a module system, you have a file system, you have all of these, you have the NetBeans core runtime, plus you have one single window where you've removed the tab and you've added your own desktop pane and internal frames, and these can communicate however you like, but in this case, also using the same mechanism. So I'm using nodes inside the panel inside the internal frame. So that's one situation that is quite common. Another one is, let's say that we're creating our own IDE now. So one place where the desktop is very popular is for creating software development tools. So what you can do is you can include not only the modules from the NetBeans platform, but you can also include the modules from the IDE, not from Java specifically, not from any particular language specifically, but just the IDE. So what does the IDE provide that the NetBeans platform doesn't provide? So for example, the concept of projects is an IDE functionality. So here you have this projects dialog, and there's a project API that you can implement and register the project implementations into this dialog, so that the user of your IDE for your own language or your own tools that you are creating can create projects of your type. You can see that there's a lot of functionality, run project, and these are unimplemented, unregistered, so they're grayed out. But so now you have a complete framework for creating an IDE for some technology, whatever that technology is. Plus, you already have integration with Git Mercurial Subversion built into the IDE skeleton before you've even begun doing your specific coding. So this could definitely be a useful thing, an infrastructure for IDEs. And one example of this is Microchip, which has created interesting IDE of its own on top of the not just the NetBeans platform, but also NetBeans IDE. And the last Windows system related thing I wanted to show was another way of looking at the Windows system, which is also quite common. And that is full screen mode. So there's full screen mode built in, and let's say you're creating some kind of air traffic control application. Now what you see here comes straight from a tutorial, so all the steps are provided, but you see here a map, and there's many open source map technologies that you can use. There's also very nice commercial products like a Luciad map that is used in NATO's application. So you see a map, you see we're in full screen mode, you see the menu bar, there's no toolbar. Here we've chosen we don't need a toolbar, and you can see all the standard menu items. But in addition, these windows that you see here floating above the map, let's say I click on something, let's say down here. So you can see that this, so here is the current window, where I am currently. So I click on a location, and information about the currently clicked location is added. So in some cases there is nothing available there. So here you can see, for example, this is the currently clicked location, and this is the history of all the locations that have been selected in the past. So we click somewhere, and the top window shows the current location, the bottom window shows all the locations that we've been to. Kind of simulating a scenario that could be quite useful in air traffic control or in general in geospatial applications. And there are many examples of geospatial applications. Also, the AgriSense project that won the Duke's Choice Award yesterday is open source. So you could learn from that. There's also a subset of that AgriSense project that has been published separately into a Maven repository, from where you could pull it and include it in your application. So there's a lot of support for this kind of application. And a lot of people with experience creating this kind of stuff. And this is never going to be browser-based. It's always going to be a desktop-type technology. Okay, so the windowing framework, you've seen the selection management. Just to show you the action framework that I mentioned, if we have or let's use one of the existing ones, the air traffic control system. So here is flight control module. So you can see also, so I'll close the other ones, that a module system is really nice. It's not what one sometimes thinks, okay, so now I need to think about how to, this module system, I have to use it now. You don't really have to break your application into modules. You could have one single module. Then again, you can't really call that a modular system. But it's completely possible to have all your code inside one module. And that's a typical initial step in the creation of the application. But at some point you think, well, this part of my code I want to always provide as the core of my application, but this part I'd like to provide separately, maybe for money or to specific users. And then you will, in a logical way, start thinking about modules, and you'll separate out that code into another module, each module providing a different feature. So here we have this flight control module that provides a window with some information. But let's add a new menu item. So normally, if you want to create a menu item, you will find in your application where the menu bar is created, and then you will find a reference to the menu bar, and you say menu bar add, and then you create your menu item. In this case, there's this handy tool in the IDE which lets you create menu items and toolbar buttons. So in this case, we say it should always be enabled. It could be conditionally enabled, so for a particular object. So if a object of my kind is in the context of the application, then enable this particular action. So that's so for example, when the context is savable, then enable the action. So in this case, menu item, it could be a toolbar button, but here it will be a menu item, and it's in flight control, so we'll call this one define flight, for example. Define flight action. Define flight. And actually what we're creating here is not an action so much as simply an action listener. So we'll call it define flight action listener. So click finish. And so here we have it. Oh, wait, let me just fix the... there it is. Okay, fine. So what we have is the action listener. But what is really interesting is we only have an action listener. So porting to the NetBeans platform, when it comes to your actions, is a question of copying action listeners, abstract actions, all your action classes directly into modules, and then you need to create these annotations. Because what happens when the module is compiled, these annotations are turned into entries inside of the file system. And the way that is done is, when this is compiled, an XML file is created. This XML file is registered inside the file system of the application. So what we will get from this, and I will show this, so I will build this module, and you can see here that an action reference is set. So path equals menu file. So in the file menu, there's going to be an action created. Let's see if I can make this bigger so you can actually see it. So you can see here that there's an action reference for the file menu. So in the file menu, there is going to be a menu item. It's going to be created. And the menu item is going to have this display name, define flight. It could have an icon as well. And when that define flight menu item is clicked, whatever we define here is going to be performed. So if I build this module, and I go to the files window, what I see is in the build folder, what is created is a layer file. So this is an XML file. You can see here the external, most external tag is file system. So this is a contribution to the file system. Each module can provide one of these. And you can see here actions. So there's an action here, the define flight action listener. So the action is defined. And there's also a menu folder. And in the menu folder, there's a file menu with a reference to a shadow file. So not to the actual instance. So this is like a system link. So we have the instance file referenced in the actions folder, and we have a link to it in the menu bar. We could have a link to it in the toolbar in multiple different places. And we link to it. So once we click on the menu item, we link to the actual instance, which is then created at that point. And so there we would have our menu item. So if we run this again, you will see under the file menu that we have a new action. So this is the nice thing about this, first of all, is that this is a standard mechanism for registering actions. Secondly, you don't need to care about anything except what happens when the user clicks on that particular menu item or toolbar button. You don't even need to care about what needs to be enabled. So here you can see define flight has been added. So, and you don't even need to care about how this is enabled. So let's say this should be enabled. So I'll create a constructor. If, so let's say there's a string. Now, when this is now compiled, this module, what will be created is a different kind of action, a registration entry. And let's clean and build this module. What is now created is we're still running the application. But anyway, a different action registration is generated from this, which says a string needs to be in the context in order for this action to be enabled. And then if some other part of the application publishes that particular object, automatically this action will become enabled and the user will be able to click on it. So by passing in an object into the constructor, you're saying under what conditions should this action be enabled. And that handles the enablement for you. It will be disabled until there's a string in the context. Because under the hood, this maps to an internal NetBeans action class that does all the enablement. And if we look here, does all the enablement for a particular type. So from the constructor, the annotation processor took the information to set it as the value of the type attribute, and that information will then be passed into the internal action class, which will enable under those conditions. Okay, I think we should be getting to the end of things. And this whole update mechanism that you see in the NetBeans platform can also be part of your application. So this dialog is just some predefined modules that you can include to install and distribute new modules, new features to other users of the application. JavaFX fits very naturally into this, and this morning there was a great tutorial by Paul and Gail Anderson on this particular topic. There's another session coming up about this. JavaFX fits very naturally into this whole story. There's a JavaFX panel that you can put into a Swing component, and into that JavaFX panel you can put JavaFX charts or the JavaFX web view. Then it becomes possible to style your Java desktop application because JavaFX supports CSS style sheets, and then you can create style sheets to style the application. It also lets you, if you like, migrate step by step to JavaFX. You don't have to buy into all of JavaFX if you don't want to. You can take the pieces from it that you find interesting. If you don't want animations and flashy stuff in your banking application, which would make sense, I guess, then you don't need to include those. But the parts that make sense, you can include. And that's really a wonderful thing about JavaFX 2. So, in conclusion, the NetBeans platform is an application framework for the Java desktop, whether it's Swing or JavaFX. In theory, it could be anything. So there is also an open source project for creating Scala applications on the NetBeans platform, as an example. It's very widely used. There are hundreds of applications that we know of, and thousands that we hear about, but where they say we can't tell you because it's secret and we'd have to kill you and things like that. There are many books and tutorials and training courses, and there is also a very handy cheat sheet which introduces you to everything that you've heard with references to where you can go to. And these are free for anyone here who wants to give me their business card, and your business card will not go anywhere else. I will use it to contact you to say, hey, do you want to join a training course? And if you say no, I will never contact you again. But it's just, it would be very nice to be able to interact with you and ask you about what you would like from the NetBeans platform. If you find it interesting, we'd really like to help you and have you join courses and things like that. So they're up here and waiting for you. So there are also many other sessions throughout Java 1 that you can follow. There's one interesting one on Thursday, which is a NetBeans platform discussion panel, where you'll see six or so different NetBeans platform applications being demonstrated by the architects and developers working on them. So you'll see some actual applications. You can ask people how they did it and how long it took and things like that. And there's also a session, there's sessions about modularity, about the NetBeans platform. There's a project called Neuraf, which is also a NetBeans platform application for neural networks, which you can also attend. Are there, in the 1 minute that I've carefully assigned for question time, any questions? Yes.
Can you do, in JavaFX, can you do standard screens like labels and fields, text fields and things like that?
Yes.
So you can write your whole application in Java.
Yes, you could do that, definitely. Yeah. Except that you wouldn't have a window system if you want to do it that way, but you could put your JavaFX components into the NetBeans window system. Yeah. Yeah. Yes.
I think I noticed that I do both Scala as well as Java-based applications, and I noticed some of the things like the annotations don't seem to work for Java-based classes, and then the Scala supports a little intermittent. Is there any plan to keep that up or make Scala a little more first class than these applications?
Well, for Scala for NetBeans platform application development. Yeah, the Scala support for NetBeans is contributed by an external person. It's not officially supported, but the fact that he created that plugin means that he knows about the NetBeans API. So theoretically, that it could be extended to be used for NetBeans platform development. But it would be interesting to see what he thinks about. But there is actually a very interesting Scala-based NetBeans platform application used for learning Scala, and it's written in Scala on the NetBeans platform. So that's the one I know of, but they've definitely figured it out themselves, and there's no official path to that. Not so far, until you start blogging about it and demanding that this happens. Okay. Thank you very much. If you have other questions, I'll be here for some time.